Hello there, and welcome to the September 2024 edition of the Manitowoc Ice Monthly Spotlight. Today we're going to talk about using the sequence of operation as a troubleshooting tool. We're going to stick with the Indigo Next Series ice machine today. We may do this again with Cool Air, Neo, any of our other machines. I've spoken with tech support of other manufacturers. I've spoken with our internal here and a number of people. If you do not know what's supposed to be happening when on an ice machine, I don't care how long we've been certified refrigeration, it's not going to help at that point. The sequence of operations is the single most important thing to know before we ever try to hook up gauges or try to diagnose a machine. If this unit will not go through its paces with its input devices, its output devices, and everything else, we're going to be just as lost as somebody who has never been certified refrigeration and who doesn't know how to use a screwdriver. So that's why this topic is so important to us and what we're going to cover today. So at the end of the spotlight, just like we do on all of our other spotlights, we're going to have a quiz at the end. It should be about 10 questions. You'll end up seeing that you get a grade at the end. Please provide everything that we do ask for. We're going to ask for who you are, your name, the company you work for. An email address is going to be the key here. We need that email address so that way we know how to reach out to you because we do a swag bag drawing each month, but also just this way we know to be able to reach out to you with your results as well as a PDF version of this. Also, as silly as it sounds, please click submit at the end. We won't know what's going on. You won't have actually gotten any of that data to us unless you submit it to us when you're done. All right, so the sequence of operations. The definition of the sequence of operations is what's supposed to be happening when. So you see there towards the bottom left, you've got a screen that just says making ice. Well, that's the home screen, everybody. Home screen is great, but it doesn't tell us what's happening. That there is for the customer. You'll see making ice, off, program mode, you may see full bin, you may see any number of things that could have come up on that screen. Indicators such as a triangle with an exclamation in it, an envelope for messages, all those other things. That's not what we're going to cover today. We're covering the sequence of operations. So we also have a chart here showing what's supposed to be energized when, a picture of our control board, and a picture of one of our output devices. In the case of the bottom right there, that is our water dump valve. Where can this information be found? Well, the energized charts can be found in the applicable technician's handbook. You can also find this information on the inside of the front door of any ice machine. You'll also find the cleaning procedure there if you've never done a cleaning. It can be found in all of the handouts done at our level 2 field trainings, as well as the level 3 factory school. It can be found in a number of places. Ideally, the technician's handbook that you get from your schools or that you order or you've downloaded for free on our website, that's going to tell you what's supposed to happen in each part of the sequence of operations. It'll tell you how long these parts are, such as the water purge, the pre-chill, minimum and maximum times for the freeze. We're going to get into all of that. All right, so where do we start? Well, from an off state, the first thing we're going to do is purge the water trough. Regardless of if this is a brand new startup or anything else, the machine's been off for 70 straight days. We're going to start in a purge. This is a 45-second timed water purge. Now, if you navigated into service, went to data, went to real-time data, you'll have three options in real-time data: time and temperature, inputs, and outputs. Any one of those three will tell you what you're doing in your sequence of operations. But during the water purge, independent of an input device, it's just a timed power dump on the Indigo Next. So the pump and the dump valve are going to be energized. So you'll see the board there. It's calling out a little red star indicator showing you your LEDs. Those two, the second from the top and the second from the bottom, are going to be energized, letting you know, hey, I'm sending power out to this device. Now, let's say that trough really was full of water and it's not moving anywhere. Well, you could actually go and check the components themselves, the dump valve, check across the solenoid. 115 volt unit, I expect 115, 208, 230, I expect whatever you're getting from the wall, the breaker, however this machine's wired up. But that's the key of what we're looking for. And the board will tell you, so will the screen if you navigate into real-time data. This one gets a little bit confusing because if you are in real-time data, the screen doesn't change. It stays in water purge, but you're actually in an equalization period. So at this point, we're going to drop out the water pump and the dump valve, and we're going to energize any harvest valve or valves if there's multiple. And keep in mind, there's not an independent relay for the air pumps. They're wired in series with the harvest valve. So if the harvest valve has power, so does the air pump. And if that air assist pump does not run, but you've got power to the harvest valve, well, then you know you're looking at an issue with that air assist pump. Either there's a loose connection, not getting voltage to it for whatever reason, or the pump motor itself just doesn't work. That's where you'd be able to check here. But again, the screen in real-time data is still going to say that you're in water purge. At this point, we're going to go into the refrigeration startup. Again, the screen still says water purge. It's just because that screen can't react fast enough with that 5-second bit there. Well, 2 5-second bits as you see on the screen. So at this point, we're going to energize the contactor. Keep that system equalized so that way we do a softer startup on our refrigeration system, and we're going to let the compressor fire and start cooling this system. Now, once you're here, you're going to be in something we call pre-chill. Pre-chill is there to do 2 things. We want to fill with water. That's why you'll see the water fill valve come on. And we're pre-cooling the cabinet. So we're cooling that evaporator down below the temperature of the water to help prevent slush. A lot of manufacturers fight it different ways. We do it with a longer initial pre-chill and an additional squirt of water, which we'll show you here once we get into freeze. So pre-chill is 2 minutes long in the first cycle from an off state, whether the machine was turned off or it was off on a full bin. Anytime you do an initial startup where you have a water purge, an equalization, and a startup period, pre-chill is always 2 minutes long. So what we're going to do is we're going to fill. So the water inlet valve will energize, and it's going to fill until that water level probe, all 3 of those sticks are touching water. And if you were in your real-time data screen under inputs, water level low would go from not sensing to sensing, and then water level high would go from not sensing to sensing. So that's the key here. Yes, we fill with water during pre-chill, but we have an input device, the water level probe, that tells us if we need water or not. So we'll get into that a little bit later, but that's the key that I want you to remember here. We're running the compressor to cool the evaporator to prevent slush and make some ice, and we're filling with water. All right, so scenario 1, said we'd get to it. We're getting to it quick. Unit's not filling with water. Here you see, we're in pre-chill. That's hours, minutes, and seconds. We're 31 seconds into pre-chill, and you notice there's no water in that pan. Well, what you would have wanted to do is hit that menu icon on the home screen. Looks like those 3 stacked lines in the bottom left. Go to Service, go to Data, Real-Time Data, and then Inputs. We're in the input screen here. What you'll see is 31 seconds into pre-chill, water level low and water level high, though both probes say they're sensing. Well, this board can only do 2 things. What Manitowoc has programmed it to do, and what its input devices are telling it to do. So you didn't fill with water during pre-chill. Well, the water probe told us that we already have water, so we're not going to fill with water. I have seen it before where as soon as you go into pre-chill, you get the briefest bit of voltage to that inlet valve, but then it stops. Well, that's because it's a predetermined bit. We know, hey, we start filling during pre-chill. The board processes, oh wait, water probe, it's sensing, don't fill. That probe is there because we don't utilize a float valve here. This is a batch water system. So if you're not getting water, this is the first issue. All right, where are we in the sequence? We already told you, we're in pre-chill. May cycle on and off that water inlet valve. Well, in this scenario, you never cycled on in the first place. Well, it's because that water probe told the board that you already had water. So if it was me, what I'd be doing is turning the machine off, unplugging the water probe, and seeing, does it stop sensing now? Oh, it does? I've got a false sensing water probe. Maybe some crusty scale buildup on those 3 sticks. Clean it all up, dry it off, pop it back in, and you're off to the races. Or maybe it's a shorted probe that can't sense. So, unit wasn't getting water here because the water probe was sensing. Well, go ahead and unplug that. What happens if it stops sensing? If not, if it does stop sensing, we're gonna investigate the water inlet valve. Let's say that really did say it was not sensing though. Too many screens gets a little hard on the screen for the viewers here, so we're gonna keep this screen. Well, if the water probe was not sensing, you need to do similar to what we did in our Ice Tech FAQ about an indigo not getting water. What you'd see is you check for power at the valve. Water probe's not sensing. If you have 115 volts on a 115 unit, or you have 211 volts on a 208, 230 volt unit, what you're going to see at that point is that you have power going to that valve and no water coming in. At that point, you're going to want to verify, do you have a water filter that's plugged? Do you even have water coming to the ice machine? Once you resolve everything outside of the ice machine, yes, Jason, I am 100% certain I took the water line off, opened up the valve, and I got water. Put that back on, power to the valve and no water. Well, at that point, you've got a restriction in your water inlet valve, or you've got a defective water inlet valve. That's where we're looking. Now, if it does say sensing, as we've covered, I think twice now, you're going to want to check, will it stop sensing when unplugged? Does it recover after cleaning? If it does stop sensing when unplugged and does not recover after cleaning the probe, you're going to need a new water probe. Please remember that we sell through distribution. Go to your local distributor. If you don't know who that is, go to manitowoc.com, click on sales, and click on sales locator. You can put in your city and state, your zip code, whatever it needs, and it'll tell you who the local Manitowoc parts and equipment distributor is in the area. All right, but now we're going to go into freeze. So pre-chill, you've got refrigeration running, but you do not have a load on the evaporator. At that point, all we're doing is cooling that plate. So when tech support here, if you have ever had me on the phone or any of my coworkers, when we ask how long your freeze is, if you didn't know that you could see how long freeze is by being in real-time data, well, you don't count pre-chill. That's the key. Pre-chill isn't freeze because you don't have a load. So at this point, if you ever want to know what the definition of freeze is, refrigeration is running, water in the trough, water pump pumping water over the evaporator. Once all those things are true, you are in freeze, you can start timing. Because there's a lot of older equipment out there that doesn't have a display, that will not tell you these things. So feel free at that point to take that definition and apply it to the old S model, the Q, the B, the J, the cool air that won't tell you what part of the sequence you're in, all those machines. During this time, we've got the water pump relay energized. The water fill valve may re-energize if we come off of the water probe early enough and freeze. That second squirt of water, it is a little bit makeup water, but mostly what its purpose is to bust up slush in that trough. Nothing breaks up slush better than an injection of fresh water. And obviously the contactor. Your condenser should be running if you've got a air-cooled machine. If your pressure builds up enough, your fan cycle switch will close, call for the fan. Water regulating valve will let water through the condenser if you get above the set point of that water reg valve. Traditional remote, as long as it's wired in accordance with the installation, operation, and maintenance manual. At that point, the fan outside runs whenever the contactor is pulled in. And if it was a quiet cube ice machine, that has pressure switches out there as well, and it's air cooled, so your fan will be running based on head pressure. We have a 35-minute maximum freeze. So for years, we had a 60-minute maximum. Even with the original Indigo, when that first came out, it was still 60 minutes. We also have a 6-minute minimum freeze. We do not want to go into a harvest every minute of freeze. Every time you go into freeze, 1 minute in. We do not bypass that on Indigo or Indigo Next, ever. Because you, as the technician with a display, can bypass it anytime you like. You can go into the menu, go to service, go to manual harvest, and initiate a manual harvest yourself. On the Cool Air line, on the Neo Undercounter, and on all the old Manitowocs, we do bypass the 6-minute lock-in freeze on the first sequence from an off state. That's there for troubleshooting purposes and because they do not have an option to initiate a manual harvest. Once we have that ice probe sensing, what we're looking for is the ice probe to touch that ice. That vibration up against there will send your frequencies. If you were reading in inputs, you would see 100 hertz and 120 hertz FFT readings. For the first 6 minutes, we set a baseline, and then we have to get 3,000 above that baseline average to initiate a harvest. And at that point, what we're going to do is we're going to go into what we call the harvest purge. You're in harvest, but the first part of it is harvest purge. If you're looking at your screen, you will not see harvest purge on the screen in inputs, outputs, or time and temperature. You'll just see harvest. For the first 45 seconds of harvest, we're going to have any harvest valve or valves, any air pumps if they're there, the water pump, the dump valve, and the contactor. Says compressor and fan. In my experience with an air-cooled machine, usually pretty quickly in harvest, if everything's working the way it's supposed to, the fan will shut off on an air-cooled, the water will stop coming out of the water-cooled condenser on a water-cooled, the fan will shut off on a CVD system, and if it's wired correctly on a traditional remote in accordance with the IOM, the fan will continuously run on that one because it's wired in series with the contactor. Then we go into the rest of our normal harvest. We're going to stop utilizing the water pump, stop utilizing the dump valve, and we're going to continue with the hot gas in a machine that has the compressor inside, or harvest valve is the proper term. The air pump, wired in series, will also run, and the contactor coil will stay energized. What we're looking for here is bin switch activation. When you go into harvest, your curtain should start closed. As it comes open and that ice falls, curtain swings all the way open, all the way closed, time to go back to pre-chill. 7-minute maximum harvest. Now, for years and years and years, until about halfway through the life of the original Indigo series, the maximum harvest time on a Manitowoc was 3.5 minutes. If you hit 3.5 minutes, you went back into a pre-chill and you tried again. Did that enough times in a row, depending on the model, the machine would shut down on long harvest or safety limit 2. Well, here we have a 7-minute harvest. We increased it. And that second 3.5 minutes is what we call a water-assisted harvest. And you'll see there. So, first 3.5 minutes, the same harvest that we've been doing since we put a ice probe into the ice machine. Just normal hot gas, draining the system out ever since we've been utilizing a dump valve. But once you get to that 3.5 minute mark, what's going to happen is the water inlet valve will energize, assuming that the water probe is not sensing for some reason, and it's going to fill until the water high probe is satisfied. At 4 minutes, whether we're done filling or not, but at 4 minutes, the water pump is going to kick on, and we're going to do a water-assisted harvest at this point. Well, we don't typically like water-assisted harvests here at Manitowoc Ice, so why are we doing it? Well, if you've gone through your 3.5 minutes, you've burned up whatever heat you had. It's gone. You've utilized it. You're down to room temperature. So we need that water for whatever reason that you didn't harvest in the normal 3.5 minutes. And I'll tell you from my experience, good working, clean, level machines with proper ice thickness, they drop in 2 minutes or less once they're in harvest. Make a full sheet of ice, go into harvest. 2 minutes or less later, that ice drops, you're back into pre-chill. Well, if you've gone the full 3.5 minutes, we're going to need some water to help us along. So we're going to circulate water during this time. And then at the 6.5 minute mark, because we like to start with a fresh batch of water each cycle, we're going to energize the dump valve and the pump will stay on. We're going to pull that old water out, hoping that we can clear this ice and drop by the 6 minute and 59 second mark. If at 7 minutes you still have not dropped, we're going to do something else, and we'll talk about that here in a second. But let's assume that we did drop that ice, whether it was at the 1 minute and 1 second mark, or if it was at the 6 minute and 59 second mark. If that curtain switch start closed opens and goes closed again within 30 seconds at any time of the harvest, you're going back to pre-chill. And if you go back to pre-chill, your pre-chill is only 30 seconds long. Now, full bin. This one is always fun for me, personally, because I've seen it before. Hey, I have a false full bin. Let's define full bin here. You can have that curtain on and start the machine, and it'll start. You could take that curtain off as soon as you do that. The only time we care about that little red circle there is on initial startup and once we're in harvest. So what full bin is, you go into harvest, the curtain starts closed. That curtain starts to open, and if it stays open for 30 consecutive seconds during the harvest sequence, you go to full bin. So if you call in and say, Jason, you know what, this machine just goes into full bin every time we go into harvest, I'd say, well, you melted. Yeah, I melted. I started sliding forward, it held the curtain open, and I'm off on full bin. Well, I hope you haven't replaced any parts yet, because the machine's doing what it's supposed to do. Everything that it's supposed to do has happened. The curtain moved, it broke the signal with the magnetic bin switch the way it was supposed to, and it shut down. What you have is what I like to call a symptom 4. You're melting out, and either you fully melt out and go into a thaw sequence after a 7-minute harvest, or you go to this full bin that we're talking about. The 2 fixes for this are 3 fixes really. Verify the install, so things like being level, the adjustment of the ice probe, make sure you're making a good sheet of ice, and the third one, is that ice machine clean? If it's not clean, scale will slow us down while we're sending heat to the plate. If we slow down, we continue melting. If we melt enough, we lose our weight. Once that starts sliding forward, you don't need refrigeration anymore. You need 2 things: a smooth, undamaged, level path, that's 1, and weight, that's the second. All current Indigo Nexts with 9.4 software, which is our current software, or going up through 9.0, might be 9.1, has a 5-minute delay for full bin shutdown. That's for air-cooled, water-cooled, traditional remote, and CVD systems. Full bin delay is 5 minutes. But what we're looking for is two things. The 5-minute delay has to have expired, and the curtain has to come closed. It's not this then, it's this and. So let's say, as we were talking before, you went into full bin right as the ice was dropping. Well, that curtain snapped closed. Well, we're at 4 minutes and 59 seconds of our delay. Got to let that time out. So if the curtain was open for 3 straight hours because you really were full, use some of that ice, curtain comes closed, you're going to snap right back on. Or if you close at the 32-second mark after it had been open, well, you're going to stay off for however long is left. So these are our current timers. We have a 6-minute lock-in freeze on all freeze sequences that we do not bypass, 35-minute maximum freeze, 7-minute maximum harvest cycle, second 3.5 minutes is that water assist. Our water fill, we didn't cover it a ton, but if you have one evaporator, the maximum amount of time that the water inlet valve can have power consecutively is 6 minutes. If it does not satisfy your probe within that time, we de-energize it because we don't want to overflow. And for the dual evaporator systems, you have an 8-minute maximum. And here you'll see what's there for what's energized when and what we're looking for in our sequence of operations. All right, that ice thaw, talked about it a little bit. This is what happens after a 7-minute harvest. That curtain was closed at the beginning of harvest, and it was 7 minutes later without ice ever falling. You're going to go into something that we call the ice thaw sequence. Compressor's going to shut down. Water pump continues to run. Water inlet valve fills until the high probe is satisfied. We're going to circulate water for about 3 minutes. We're going to dump that old water down the drain. And we're going to fill back up, and we're going to do this 18 times. Where the confusion comes in, the home screen does not tell you what part of the sequence of operations you're in. The only thing that the ice machine home screen will tell you is making ice, program mode, or off. That's what it's going to tell you. So it'll say making ice. That's why it's so important to know that you can utilize this screen that's not lit up behind me, but you can utilize it to navigate into your service menu and see what part of the sequence of operations you're actually in. Depending on the size of the machine, that ice thaw sequence is going to take an hour to an hour and 45 minutes. If you want to get out of the thaw, press the power button once you realize you're in the thaw and start a new sequence of operation. That curtain can open and close 7,000 times during thaw. It's not going to kick you out of thaw. Thaw is a timed event. All right, so how do these things help us? Big thing that I want to know, hey, that picture there on the bottom left, that's telling me that's my harvest valve. I've got my contactor. I know what's supposed to be energized when, so if I'm not getting the reaction that I'm looking for, let's say I'm in harvest, I've got no heat. Well, go check, do you have power? Well, you know you're in harvest, go look for power. Here, we're in our inputs. Are we in harvest? Well, that time is completely wrong, but we're in harvest. Go verify power to the valve. Do you have power to the valve? You do? All right, well, the valve got its signal from the board. The valve didn't open. You got a bad valve. Oh, you're in harvest? And you don't have power to that valve. Let's be 100% sure. Go ahead, check there. You could also follow your wiring diagram. Wire 56 on an indigo is going to be common to everything, and the red wire 61 is going to be what you'd look for your harvest valve on a single circuit evaporator. And again, knowing what's supposed to happen when. Hey, what's supposed to be energized here? If you said you still had the water pump running in harvest, my first question would be, how long have you been in harvest? Oh, 31 seconds. Well, the water pump's supposed to be running. At 45 seconds, we stop running that pump. Also, what do we want to know if we're just running water and it said making ice? Hey, maybe we're in that thaw state that we referred to here a minute ago. You want to know what part of the sequence you're in, because if it says it's making ice and you don't hear a compressor or a fan on an air-cooled machine, no sign of refrigeration. The home screen, that's not for you and me, the technician. We need things like real-time data. Hey, look at this. We've been in thaw, not sure how long, but T1, which is measuring my liquid line temperature as it exits the condenser, is 85. T2, my compressor discharge line on a self-contained ice machine or traditional remote, is 85. And the evaporator on a single circuit, so inlet is T3, outlet is T4, are both sitting at 50. So yeah, we're not refrigerating, but it's because we're in thaw. And what do our inputs or output devices tell us? Our output page, it's going to tell you what is energized when. You have 6 relays and 6 outputs. If you've got a dual circuit evaporator with multiple harvest valves, you're going to, a dual circuit, not dual evaporator, dual circuit. So one plate, multiple circuits. They're going to be energized by the same relay. If you have dual evaporators, you'll have harvest valve 1 and harvest valve 2. So you'll have separate relays for separate harvest valves. But it's going to tell you what's supposed to be on when. Your input devices, that's something that plugs into the control board. So curtain switch 1, open, curtain switch 2 is closed. This must be a dual evaporator system, and we're trying to harvest. High pressure switch, that plugs into the board as well, so that makes that a input device. We give you 2 bits of information for the ice probe. Ice probe, again, plugs into the board, plugs in, input. So we're going to tell you what the 100 hertz and 120 hertz frequencies are doing. And your water probe, single device, but 3 probes, a common, a low, and a high. We're going to tell you what both of those are sensing. Keep in mind, safe mode, we're not going to go deep into this, but let's say on that screen there, if we finish harvest on the input screen and water low, as it's sensing now, continues to sense at the end of that harvest, we're going to go into safe mode. It's also going to flag a water fault. All right. Long freeze, but we do have water in the trough. Hey, look at this. We've been in freeze for about 18 minutes. Most of our machines make ice faster than that, and we're using this. Let's say you have almost no ice on the evaporator. This might be a good time to be looking, hey, look, everything filled the way I expected it to. Everything's going the way I expected it to. It might be time to start doing a symptom 2 flow chart. And the outputs, again, hey, if we're not making ice, water pumps on and you're not moving water, let's go ahead and verify, is there still water in the trough? Yes, we saw that on the input screen. Water pump is on, checked for power. Yes, we have power, looking at a water pump problem. But again, verify everything's working correctly the way you need to. We're not going to go into all the ins and outs today. It's about knowing what's supposed to happen when. You have flowcharts in the technician's handbook. Symptom 1 for a machine that's shutting down. Symptom 2 is a long freeze condition. Symptom 3 is a long harvest where the ice doesn't melt. And symptom 4 is a long harvest where the ice does melt. All right. Thank you for viewing today. Please take the quiz and make sure you hit submit so we can get your information and put you into our drawing. For every 25 quiz submissions, we will draw 1 name. We've never had to draw 2 yet, so let's try to get up to 50 for once. And now I'm going to leave this up on the screen for you. We will put that URL into the chat. This will allow you to take your quiz. I want to wish you good luck. Again, my name is Jason MacDonald, Technical Service Trainer at Manitowoc Ice. Thank you for tuning in. If you liked what you saw today, please like and subscribe to our YouTube channel. Have a nice day.